In the last class, we have discussed about few important terms in coordination chemistry. Among that terms, you have heard about ligand. What is a ligand? Any species which can donate lone pair of electron to the central metal ion or atom is known as a ligand. Some ligands can donate only a single lone pair. Some others can donate more than one. It can be 2, 3, 4, etc. So, we have introduced a term density in the last video. It is the number of lone pairs donated by a ligand at a time. Number of lone pairs donated by a ligand at a time. If a ligand donates only one lone pair, it is called unidentate ligand or monodentate ligand. If it can donate two lone pairs, not two electrons, two lone pairs. While writing in examination, you should do it correctly. If it is two, we can call it as bidentate ligand. If ligand is capable to donate 3 electrons at a time, it is a tridentate ligand. If it is 4, we can call it as tetradentate ligand. We have pentadentate ligand for 5 lone pairs, and we can call a ligand hexadentate if it is capable to donate 6 lone pairs at the same time. At first, what is a monodentate ligand? Those ligands which are capable to donate a lone pair to the central metal ion. They can be classified as anionic, neutral or cationic. Anionic means they have negative charge like Cl minus, Br minus, OH minus, NO2 minus. They can donate a lone pair. Neutral ligands, ammonia, water, carbon monoxide, methylamine, etc. They are also capable to donate a lone pair. Here nitrogen is the donor. Here oxygen is donor. Here also we have carbon as the donor. Here nitrogen is the donor. In cationic ligand you have NO plus or NO2 plus, etc. as examples. For bidentate ligand, they are able to donate 2 lone pairs at the same time. Example, ethylene, diamine. Ethylene, diamine, CH2, that is ethylene. NH2, NH2, then diamine. Here, both nitrogen carry lone pairs, so they can act as donor atoms. Ethylene, diamine is represented as ene. It is the shortest representation or symbol of ethylene diamine. Ethylene, that is En. Then you have to remember that for one ethylene you have 2 amine groups, ethylene, diamine. Second one, it is oxalate, COO minus, COO minus. Here also you have 2 donor atoms, they are oxygen. This is bipyridine, 2 pyridine rings are connected. Here we have 2 nitrogen on 2 rings and they can act as donor atoms. So they are also bidentate. And you have one more kind of bidentate, CH2 COO minus and NH2. Here nitrogen is donor in left side while oxygen is donor in right side. What is the difference between first three and the fourth one? In first three cases, donor atoms are same, either oxygen or nitrogen. But here oxygen is donor at one end and nitrogen is the donor at other end. So what to say? The first three ligands are called symmetrical bidentate ligands. What is the name? Symmetrical bidentate ligand. This one, and this one. While this one is unsymmetrical bidentate ligand. These two terms you have to use in stereochemistry of coordination compounds, symmetrical and unsymmetrical. Depending on the symmetry of the ligand, there will be change in the stereochemistry that we can discuss in future videos. In tridentate, the only change is that in the last case you have one ethylene and two amine. Here you have two ethylene and one amine, other amine and a linking amine. Three amine groups: ethylene, diethylene, triamine. First one was ethylene, diamine. This one is diethylene, triamine. So shortest form is diene. Diene means three more amine groups are present. If so, what is the example of tetradentate? Very easy. You have to increase ethylene group one more. Two ethylene group can be raised to 3. CH2, 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 CH2. Connect with NH. Again NH. Here terminal NH2 and NH2. Here you have one donor, second donor, third donor and fourth donor. 4 donor atoms. All of them are nitrogen and they are tetradentate ligand. Now name is triethylene tetramine. So short is triene. In the same way, we have penta also. You can extend it to pentadentate ligand. In hexadentate ligand, we have other example, that is EDTA. What is EDTA? Ethylene, diamine, tetraacetate. Ethylene, only one ethylene. Diamine, this is NH2, ethylene diamine. But we have to add 4 acetates, that is tetraacetate. So these two hydrogens are displaced by 2 acetate groups, CH2 COO minus, CH2 COO minus. Same way, substitute these two hydrogen by CH2COO minus, CH2 COO minus. What are donor atoms? This one is oxygens and these two oxygens. So here you have 4 oxygenous donor atoms and 2 nitrogen donor atoms. Totally 6 donor atoms. Then it is hexadentate. The next one is flexidentate. they can show variation in their density. When central metal ion changes, they show variation in their density. For some metals, sulfate donate two lone pairs at the same time, this one and this one. Then it is a bidentate. But for some other metal ions, it can donate only one lone pair. This one is not participating in donation, so it is a monodentate. So sulfate is a ligand which can act as monodentate as well as bidentate depending on the condition or depending on the metal ion to which it has to bond. Other example is carbonate. Here normal coordination number of cobalt is 6. Here we have 4 ammonia. So carbonate is a bidentate ligand. Then 4 plus 2 will become 6. So carbonate is bidentate. Here you have 5 ammonia. So only one valence is vacant. So here carbonate acts as single donor or monodentate ligand. So carbonate itself acts as monodentate as well as bidentate. Other example of flexidental ligand is the CDTA. It can donate maximum of 6 lone pairs. But if the acceptor metal ion is not capable to accept 6 electrons, then this ligand is ready to donate 5, 4, 3 or 2. Then they can act as bidentate, tridentate, tetradentate and pentadentate also. So their density is not a fixed one. They can show variation in the density. So we are using the term flexible density, that is flexidentate. Next one is chelating ligand. They are actually polydentate ligands. So they are not monodentate. They are polydentate ligands which when bonded to metal ion, they can form cyclic complexes. Example, Cu2 plus. When combined with ethylene diamine, that is shortest form, you will get Cu. What is the structure of ethylene diamine? NH2, CH2, CH2, NH2. NH2, CH2, CH2, NH2. Charge of copper is shown here. Here this is a bidentate ligand, but when bonded to copper, it forms a cycle here. Here also you can see a cyclic structure or ring structure. So this ligand is a chelating ligand. Lots of chelating ligands are there. They are important in biological field also. Here ligand is a linear one, but when bonded to metal ion, it form a ring. But in some other conditions, ligand itself is cyclic and metal ion bind to the cavity at the center of the ring. Ligand already is a cyclic one. Example, porphyrin ring, which is the part of hemoglobin. To the central cavity of porphyrin ring, ion can coordinate. Such ligands are called macrocyclic ligands. They are a kind of chelating ligands, but we are commonly using the term macrocyclic ligand. They are cyclic ligands which can bind with metal ions. Then you have to see ambidentate ligand also. Cn minus, NO2 minus, SCN minus, etc. are ambidentate ligands. For Cn minus, they can bond with the metal using carbon or using nitrogen. MnO2 or MONO, MSCN or NCS. Here either carbon atom donate lone pair, otherwise nitrogen, either nitrogen or oxygen, either sulfur or nitrogen. So they are monodentate ligands, since they can donate only one lone pair, but that can be donated by both atoms, but at a time they donate only one, either carbon or nitrogen, nitrogen or oxygen, sulfur or nitrogen. So they are monodentate ligands having more than one donor atom. Such ligands are called ambidentate ligands. Thank you, friends.